The question whether digital pathology is good enough is already answered, or at least is answered for you at this point of your digital pathology journey if you're looking into validation. Now the question is how to validate. In this video, I'm going to show you an approach that worked extremely well for a good laboratory practice compliance setting. I'm going to show you the pathology portion of a GLP validation of a digital pathology system. If you're working in a different regulatory framework, then you will need to adhere to your specific guidelines. But if you're working in GLP, this approach is going to be perfect for you. This is a fragment of a presentation and a webinar I gave during the Digital Pathology and AI conference in New York, and it shows how this validation was done for a large contract research organization. My name is Alexandra Zuraw. I'm a toxicologic pathologist, and I'm going to tell you about how digital pathology empowers toxicologic pathologists. And I believe I am only a good pathologist, or you can only be a good pathologist when you do digital pathology at the moment. And I've heard it a couple of times in the talks yesterday and today that digital pathology is now the way of doing pathology, right? And actually, this conference should not be called digital pathology anymore. It should be called pathology. Why is it important to me specifically? Because Charles River supported the development of approximately 85% of FDA approved drugs in 2020. So 85% of what was approved went through Charles River. And that means that whatever lands on my desk at some point, when it makes it to this approval, it's going to be given to people. So that's a bit of a high responsibility. I think it's important work that I'm doing, and all my colleagues, all my ToxPath colleagues are doing. But because the drug development cycle is so long, it's like 10 to 15 years, and pathology is just one part of it. It's like, I don't know, it's often not enough of a motivation, like to do your best, because you're contributing to a drug that's going to be given to a person. Yeah, maybe if it gets approved or maybe not, and there's so many people involved in this process. So to me, actually, there was another event that motivated me very much to do my best. When one example of this, so we read studies as toxicologic pathologists, and then sometimes those studies get reread. For example, if one company is acquiring another company, they have to do a due diligence on the drug, and they look through the data. And sometimes when there are problems, you have to go back to the slides and check the slides. And I have overheard conversation of my colleagues talking about a case like this, where changes were missed. And that had a big impact on what later happened with the drug and with the deal and everything. And that moment is like, I don't want to be the person that misses things. I'd rather ask like 10 times than miss stuff and cause something like this down the road. And it's not, you don't get immediate feedback for that, and not always. But I very much didn't want to be that person that misses stuff. And I still, some people are super passionate about like always investigating something, and that motivates them. To me, this is a very high motivation when like I don't want to be the person that misses things. If I can move my slide. Yeah. So at Charles River, we have over 150 pathologists, and we have over 1,500 years of experience combined. Actually, I calculated we have 167 pathologists and 1,891 years of experience. So like in 5 lifetimes, I don't know how many lifetimes I will have to live to accumulate this type of experience. And with digital pathology, I can tap into this experience with a click of a mouse, with a screenshot, with like just sending my people messages on Teams. And I have over 160 colleagues that are on this messenger, and we are in different time zones. Charles River is global, but I can ask them questions anytime and they can answer. I don't have to knock on their doors anymore. I work from home, so I wouldn't be able to do that anyway. So that's like a no-brainer. We can consult and it's fantastic, but still in the back of especially pathologist mind is like, is it really good enough? Can I really be sure that those digital images are really as good as glass? And in the keynote lecture on the first day, we heard that the pathologists in Mackenzie Health in Ontario, they needed, I think, like up to 6 months of having glass and digital. So they had to convince themselves that it's good enough, even though they were using medical devices that are FDA approved. Obviously, they work in a lab in a regulated environment. Everything was validated. But still, today we heard this as well. Like the change management in the pathologist community is pretty difficult. So I can tell you it's good enough. But obviously, I am biased. So let me tell you how we validated it to be good enough. I'm going to tell you about the pathology portion of our GLP validation. GLP, good laboratory practice, is a bigger validation effort than just the pathology scientific part. But I'm a pathologist and I was scientifically involved in this. And let me tell you what we did. So we listed points of interest on the slides that are relevant for pathologists. Then a pathologist number one identified the points on the slides, and then pathologist number two found the same points of interest on all slide images. What are points of interest? Let's start with that. Points of interest are the things where everybody thought, maybe it's not that good there. And we had so we surveyed all of our pathologists at Charles River. So we surveyed all the pathologists at Charles River and asked them, if you were to read slides digitally right now, what would it be that you don't believe you will find? And there are a couple of things that MD pathologists don't look at that I will show you later that caused concern. And also there was an effort going on in the path community working on a list of those challenging lesions, right? So this is the literature part. So then we collected slides. As a toxicologic pathologist, we look at the different species, laboratory animals. So we had collected slides from different animals, different stains, different organs, everything that we use for our work. We did not do frozen sections. This was just for FFP. Then we compiled glass slide and whole slide image validation set. And then pathologist number one, my colleague, she looked at glass and found some things that were of interest from this very list that we had at the beginning, recorded them. Then she looked at the whole slide image, but she didn't look for the stuff in the whole slide image. She just looked at the whole slide image and said, me as a board certified pathologist, I decided this is a slide of diagnostic quality. So she did that. And then I did the same exercise of checking the slide and without looking for the point of interest, checking, okay, is it of good diagnostic quality for me? Yes. And then I went and looked for the points of interest. So this is how our validation script for this part looked. So we had over 100 slides, I don't know, 112 or something. And in each of the slides, she told me what I'm supposed to look for. So I knew what I was supposed to look for. And I know especially my online people are super interested what those lesions were that we were looking for. So these were mitotic figures. We have seen them here in the conference many times. Viral inclusions, intracellular parasites, bacteria, intracellular pigments, eosinophilic granules, hyaline droplets, intracytoplasmatic basophilic granules, single-cell necrosis, microvascularization, crystals, axonal degeneration, foreign material, and basophilic tubules. So this was all included in our set of slides. Not every slide had one of these, but all of these were included. And then I went and checked if the stuff to find was there. And as you can see, everywhere I could check off a yes. And here I want to tell you, because in the clinical space, you often go and compare interpathologist concordance on those slides. We didn't do that. We used an approach that I call method non-inferiority, or it is officially called like that as well. We basically compared two methods and said that the new one is non-inferior to the old one. The digital slides are non-inferior to the glass slides. So I knew exactly where to find the stuff, but I was looking for it on digital. She was identifying it on glass. So we went for method equivalency. We did it to account for the different experience of pathologists and mostly that, but also there's not like a set of classical lesions for toxpath. There are those challengings, but you cannot really anticipate what you're going to see. Like it's not that you're diagnosing tumors all the time. So there's a little bit of, you get the surprise with every study. So you need to be confident in the method and not that every pathologist is diagnosing everything the same way. So I was confident in the method, but there was one thing that one lesion, which lesions do you guys online think I was skeptical about? And I was like, I hope I see it because if not, then like all this preaching about digital pathology is like, I can throw it into the garbage. Let me know which lesion. And I'm going to show you which lesion that was. I have my toxicologic pathologist in the audience. Do you see anything here? You don't have to tell me, just like try to find the lesion. I know what I was looking for. I found it. These are the basophilic granules, and I will show you these guys here. This is something that happens with a certain class of drug called antisense oligonucleotides. So we kind of can anticipate, because if we know that this drug is being tested, then this is what we're going to be looking for. And we get a lot of like background information. We don't read those studies blind. So you know what to look for. But like if I didn't know that this lesion existed before I learned about this lesion, I like wouldn't find it here. But here I can still see it on a projected image that is streamed through whatever. So it's not even the quality that you have on a whole slide image. So that was it. This is at 80x. You can do digital zoom, and we read at 40x. We don't really do the digital zoom, but it's a tool you can use. There was another thing that was kind of difficult for me to find. That was hair shaft. So she told me, find a hair shaft inside of a vessel. So that's the hair shaft. And she didn't tell me really where it was on the slide. So I'm like, okay, let me find it somewhere. I found it. It was here. And if anybody is interested in the blueprint, how to do it, before we did it for primary read, we did it for peer review, which is something that is routinely done in toxicology pathology when one pathologist is checking the work of another one. So this is the paper utilizing whole slide images for primary evaluation and peer review of a GLP compliant rodent toxicology study. This is the blueprint, but we are working on a publication that I'm supposed to have the manuscript done by the end of next month. I hope this gives you clarity and a good material to take to your validation tier. Before you go, I wanted to let you know about something special that I'm preparing for you. I'm finally finishing up my digital pathology book. This is going to be a guide for those who are just starting, but will definitely go beyond the basics. So if you want to grab your free copy, go ahead, click the link below and get on the waiting list. And maybe by the time you're watching this video, the book is already going to be out and you can get it directly to your inbox. And I talk to you in the next episode.